Now, we've got a really big challenge as we decarbonise, as we move into an era, where we are at a vehicle level, dealing with technologies that are fundamentally more materials intense than those technologies that we are replacing.
It's not just about how do I minimize my negative impacts as much as possible, but it's also about how do I minimize negative impacts whilst maximizing the positive impacts of what I'm doing as much as possible. From a battery perspective, that's really, really important, because in this world that we're moving towards, where we're having a very rapid transition towards battery-powered technology for mobility and also for clean energy, there's a huge opportunity to not do things the way we've always been doing them and actually think about how do I have a positive impact.
Vehicle owners want different things from their car through that cycle. So the first owner wants range, they want the new car, they want it sitting on their drive, they want it to look great, and they want to be able to drive it and enjoy being able to get from A to B without any range issues. The second person might want something different, the second owner, and the third and the fourth and the fifth, maybe even the sixth. So by the time it reaches us at its end of life, that battery doesn't necessarily need to be at 70%, because those people that are driving it will want to do different things potentially.
Well, let's have these conversations perhaps around end of life that we wouldn't have had before. And what if we look at extending the life of our product massively? What if we look at cascading our batteries? And so I think that's some of the really interesting opportunities that come out of that sort of life cycle thinking as well.
It's better, in my opinion, to have a process that allows us to get the material out, to move it on. Even if it's not into batteries, it's wonderful if we can collect CAM and make it back into battery grade CAM, brilliant. But maybe the graphite comes out and maybe it's not ready to go back into batteries. But there are people out there putting graphite into cements, into geopolymers, and doing amazing things with those materials. So we don't just have to constrain ourselves into thinking that this material has to go back into a battery. We can use the idea of industrial symbiosis and move one material into another industry altogether and still be making environmental gains and sustainability impact.
So the biggest challenges that we have is that the technology of the actual battery cells is evolving on a continuous basis. And so one pack from one manufacturer will not be the same as it is in another year. So we actually harvest cells. So when we get a pack that's not financially viable to actually repair, we harvest those cells and we keep them. And that means that we can repair similar type packs going forward.
For hydrometallurgical recycling, our belief is it really needs to be done at scale. You need to build it at the largest scale you can, because you know that the tsunami wave of end-of-life batteries is coming. Gigafactory scrap is coming.
It's not just a question about why are we stopping at black mass, it's then why are we stopping at recovered CAM? Why aren't we going further and further? And it's not just a conversation about end of life and recycling, it's a conversation about the whole supply chain. What's the ambition of the UK in this sector?
Life cycle assessment has a lot of flexibility built into it, so the practitioner can always decide, well, I can limit the boundary, I can disregard certain elements, I can only focus on certain impact factors. And so that means that one study might be done where they've only looked at what their actual production emissions are, but they've ignored transport and logistics. And another study might have included that. So then those two studies will be fundamentally different. They'll come up with different results. And it's very hard to then compare them. So we need standards to make sure that when people do an LCA study on a battery, they're doing it in a consistent manner. They're taking into account all the different aspects that will impact that eventual result, and that they're not ignoring certain logistics, they're not ignoring certain elements of the life cycle.
Most of our cost in energy, CO2 and money is to build a beautiful crystal structure that allows lithium in and out. It's not so much in the materials, it's that we've built a palace for the lithium to live in. And part of our process now is to take a wrecking ball to it and get the bricks out to rebuild it again.
We talk about supply chain. Now at the moment each link is separated and there is a massive gap between us at the end and the OEM at the beginning. There isn't enough collaboration between, I'm not just talking the beginning and the end, but there isn't collaboration where they're designing the battery, There's not collaboration with the people at the end that are having to deal with it.
But we need to be all having a joined up conversation and it not happening in one company here and one company here and another one over there. Because without that need and without that push to actually get us all talking, then it becomes very much a fractured system, and we'll never get what we need in terms of an actual truly circular economy. It will always be linear.